Hello and welcome to our next video in the series on the concepts of geometry. Today we'll be talking about circles. I'm sure you all know what a circle looks like. This here is a circle in my hand. By definition, a circle is a collection of points that are the exact same distance from the single point. That single point is the center of the circle. In the figure on the right, all of these points that lie on the circumference are the exact same distance from the center, and the center in this case has been marked with the letter O. And the distance between the center and the circumference is known as the radius. So therefore, the distance OA is the radius. A is a point on the circumference, so the distance between the center O and the point A on the circumference is the radius. Similarly, OB is also the radius. This is the distance between point O and B, which lies on the circumference. Similarly, OC is also the radius. OA, OB, and OC, they're all the exact same distance from the center. And what is the diameter? Any line that connects 2 points on the circumference of the circle in such a way that that line goes through the center of the circle is known as the diameter of the circle. So for example, line EF here connects points E and F and also goes through the center of the circle. This distance, EF, is known as the diameter of the circle, and it is also twice of the radius of the circle. We will now learn how to calculate the length of the circumference of the circle. Remember, the circumference is the perimeter, the length of the outer boundary of the circle. In this circle here, the outer boundary is the length of the boundary of the circle. If you want to figure out what is the length of the circumference, one way of doing this is to make the circle complete one revolution and measure the distance traveled by the center or traveled by any point on the circumference of the circle. This distance AB, which is the distance that any point would travel if the circle was to revolve one complete rotation, is going to be the circumference of the circle. So we can define circumference as the distance traveled by the center or any point on the circle in one complete rotation. To calculate the length of the circumference, we can use a formula 2 pi r, where r is the radius of the circle. We can also use the formula pi multiplied by the diameter, because remember the diameter is twice of the radius. So either you use 2 pi r or you use pi into the diameter, you'll get the same answer. And what is pi? Pi has an approximate value of 3.14 or an approximate value of 22 over 7. How do we define pi? What exactly is pi? Well, mathematicians discovered that anytime they made a circle and they measured the boundary of the circle by putting a string around it, for example, and measured the diameter, then the ratio between the circumference and the diameter was always a fixed value, and that value was 3.14 approximately. So therefore, pi is nothing but the ratio between the circumference of a circle and the length of its diameter. Circumference divided by diameter is equal to pi. It's not a rational number. A pi can also be defined as the circumference of a circle whose diameter is 1 unit. Now let's learn how to find the area of a circle. As you remember, area is the space occupied by an object in 2 dimensions. In the circle on the right, let's assume that the radius has a length of r, so OA equals to r, the radius of the circle. Then the area of the circle, the space occupied by the circle in 2 dimensions, can be calculated by the formula pi multiplied by r square. Remember, pi has an approximate value of 22 over 7 or 3.14. What value you'll take? Well, depends upon the answer options. If the answer options are all left in pi, then you don't need to replace pi with anything. If the answer is given as a numerical value, then use 3.14 or 22.7, whichever is easier to use in that particular situation. Here's a sample question for you. The question says, a circle with center O has radius 5 centimeter. Calculate part A, the circumference of the circle, and part B, the area of the circle. I want you to try the question yourselves, so please pause the video, and once you're done, you can watch the solution. And here is the solution. For part A, remember the circumference is equal to 2 into pi into r, where r is the radius of the circle. In this case, the radius is 5 centimeters, so we can replace r with 5. We get 2 multiplied by pi multiplied by 5, which is equal to 10 pi centimeters. Now, if the answer options are left in terms of pi, you can leave it as 10 pi and mark that as your answer. However, if the pi has been replaced and the answer is given as a numerical value, then you can easily replace pi with 3.14 here, because it'll be easy to multiply 10 with 3.14. So let's do that. 10 multiplied by 3.14 equals to 31.4 centimeters. So the answer is 31.4 centimeters. For part B, the area of the circle, we know that the formula for area is pi into r square. The radius again is 5, so we can replace r with 5. We get pi times 5 square, which gives us 25 pi centimeters square. Remember, the unit for area is always unit square. So this would be centimeters square then. You can leave the answer as 25 pi centimeters square if the answers in the question are left as in terms of pi. However, if the answer is given as a numerical value, again replacing pi with 3.14 will be the easier choice. So 25 times 3.14 will give you 78.5. So the area would be 78.5 centimeters squared. Now that we understand about the circumference and the area of a circle, let's talk about sections of a circle called arcs that result in something called a sector. Remember, the arc is nothing but a curved section of a circle, and when you take out that particular piece from the circle, that particular piece, like the slice of a pizza or like the slice of a round cake, is what is known as a sector. In the circle on the left, I'm going to create a sector, as you can see, which results when I mark the arc AB. This arc is known as the minor arc AB. Why it's called the minor arc? Well, because the angle at the center is less than 180 degrees. Whenever an arc is created by an angle at the center less than 180 degrees, that particular arc is known as the minor arc. And the central angle is nothing but the angle that the arc creates at the center and between the two radii of the circle that act as the borders of the sector. Now, when you create a particular sector from a circle, a smaller sector like I have done on the left-hand side, you also end up creating another bigger sector, a much bigger sector that would be called a major sector. The arc in this case would be again arc AB, and we will refer to it as major arc AB because the angle in the middle is much bigger than 180 degrees. So major arc is the arc created by a particular sector whose angle at the center is more than 180 degrees. Now let's focus a bit more on the sector of a circle. Remember, the sector of a circle is created between the two radii and the arc of a circle, something similar to the sector on the right side. This sector would be called sector AOB, and the arc AB is the minor arc AB because the central angle, theta or theta, is less than 180 degrees. Remember, the central angle is very important because it helps us figure out things like the length of the arc and the area of the sector. Now, the arc length or the length of the arc AB can be found by the formula circumference multiplied by the central angle divided by 360 degrees. Remember, the circumference of a circle is 2 pi r and the central angle in this case is theta. So the formula can be written as 2 pi r multiplied by theta over 360 degrees. Similarly, we can also calculate the area of the sector. The area of the sector is basically the circle's area multiplied by the central angle divided by 360 degrees. Now, the circle's area is pi r square, so we make that replacement here as we get pi r square multiplied by the central angle theta and then divide by 360 degrees. Now, one important thing that you need to remember is that because the sector is nothing but just a portion of the circle, then the ratio between the sector's arc length and the circumference of the full circle, now remember the arc length is the arc AB and the circumference is the length of the perimeter of the circle. So that ratio, the ratio between the length of the arc and the circumference of the circle, is going to be equal to the ratio between the central angle, which is theta, and the full angle of the circle, which is 360 degrees. So for example, if a question says that an arc measures 1/5 of the length of the entire circumference, then you can come to the conclusion that the central angle will also be 1/5 of the full angle, or 1/5 of 360 degrees. Similarly, the ratio between the sector area and the circle's area, the sector area is the area of the sector AOB, marked in yellow, and the full circle's area, which is the area of the entire circle, marked in blue. This ratio will also be equal to theta over 360 degrees. So if the question says that the area of a sector is 1 over 5 of the area of the entire circle, then you can conclude that the central angle would also be 1 over 5 of the full angle, or 1 over 5 of 360 degrees. A question may also ask you to figure out the perimeter of a sector. Now remember, perimeter is nothing but the sum of the outer boundaries of any shape. This particular shape, the sector AOB, has 3 boundaries: the radius OA, the arc AB, and the radius OB. So all that we have to do is just add up these 3 values, which means we have to add the radius twice and also add the arc length. Now if the radius is r, then we can write this as 2r plus the arc length, which is 2 pi r, times theta over 360 degrees. Let's try an example based on the concepts of what we've just learned in the previous few slides on the sector of a circle. This question says, sector AOB with center O has radius 12 centimeter and angle AOB is 60 degrees. Calculate the length of the arc AB and the area of sector AOB. I want you to try the question yourself, so please pause the video, and once you're done, watch the solution. And here's the solution. For part A, we had to figure out the length of the arc. An arc length is 2 pi r times theta over 360 degrees. Now the radius is given to us as 12, and the central angle theta is given to us as 60 degrees, so therefore we can make those replacements, which will become 2 into pi into 12 into 60 over 360. Now 60 over 360 simplifies to 1 over 6. So we can write this as 2 into pi into 12, which is 24 pi, multiplied by 1 over 6. Dividing 24 by 6 will give us 4. So we get 4 pi centimeters as the length of the arc. Now let's do part B. The area of a sector is equal to pi r squared times theta over 360. Again, the radius is 12 and the central angle AOB, which is theta, is 60 degrees. So let's make those replacements. We get pi into 12 square into 60 over 360. Now 60 over 360 is again 1 over 6. So we get 12 square, which is 144 pi multiplied by 1 over 6. Now 144 divided by 6 will reduce to 24. So our final answer should be 24 pi centimeters squared. And this brings us to the conclusion of part 1 of our discussion on circles. Let's do a quick recap of the important concepts we've learned in this particular video. Number 1, a circle is a shape consisting of all the points in a plane that are a fixed distance from a given point, which is the center of the circle. And the distance between the center of the circle and the circumference is known as the radius, and the diameter is twice of the radius. We've also learned that the circumference is the perimeter of the circle. It is also the distance traveled by the center of the circle or any point on the circle in one complete rotation. The formula for finding the length of the circumference is 2 pi r, or pi multiplied by the diameter. Remember, pi can be approximated as 3.14 or 22 over 7. Number 4, the area of a circle is the space occupied by that circle in 2 dimensions. The formula for the area is pi r square. Number 5, the arc is a curved section of a circle and it also creates a sector. The sector is bounded by the arc and the two radii. Number 6, the length of the arc is 2 pi r multiplied by theta over 360, where theta is the central angle. And the area of the sector is pi r square multiplied by theta over 360. Number 7, the perimeter of a sector is equal to 2 times the radius plus the length of the arc, which is 2 pi r multiplied by theta over 360. And last but not the least is that the ratio between the arc length and the circumference is equal to the ratio between the sector area over the circle's area is equal to the ratio between the central angle theta and the total angle, which is 360 degrees. In our next video, we will focus on chords of the circle and tangents to the circle. See you there.